Now we will discuss about telescope. A telescope is used to see faraway objects. A telescope makes the faraway object to appear nearer. Here it consists of two lenses. One is the objective lens, the other is eyepiece. Both are arranged coaxially in two tubes that can move one in another at the ends of the tubes. The distance between the lenses can be adjusted. Objective lens is the lens kept towards the object. Eyepiece is the lens through which we see the final image. The distance between the lenses can be adjusted with help of a screw arrangement. Now, the rays coming from the distant object are parallel. After passing through the objective, they converge at the focus of the objective lens. This image AB acts as virtual object for the eyepiece and final image is formed. And the figure shows these details. Now, to derive a formula for magnification, we can do like this. So, let us suppose this is the objective lens, this is the eyepiece. So, let us say this is the one ray of the objective, the ray coming from the object, and suppose this is the ray which is an extension of the virtual image, extend from the virtual image. Now, this is the image formed by the objective lens. So, let us suppose this is the angle made by the object at the eye, and this is the angle made by the image at the eye. Therefore, from the definition of angular magnification, m is equal to tan beta by tan alpha. So, from the figure, it is very clear that tan beta, this is equal to h by, so the image, if the final image is adjusted for infinite distance, for relaxed division, the final image is formed at infinite distance. Therefore, I can easily say that the tan beta value is equal to h, and this distance is the focal length of the eyepiece, and this distance is the focal length of the object. So, h by FO, sorry, FE by, and tan alpha is opposite, h by FO. So, that h gets cancelled. So, finally, FO over here. So, generally, a telescope is adjusted for normal vision when the image is formed at infinity. So, that adjustment we call it as normal adjustment. So, in normal adjustment, the magnification due to telescope is given by focal length of the objective by focal length of the eyepiece. The distance between the lenses is equal to FO plus FE under normal adjustment. And the final image is inverted. To make the final image erect, a third lens is introduced in between the two lenses. By inserting a third lens, the magnification is not altered. Only thing is length of the telescope increases. So what does this erecting lens does is, the image formed by the objective is made erect by the erecting lens. So, except that it won't do anything. Therefore, the total distance, if f is the focal length of the erecting lens, here it is 2f, and from here again it is 2f. So, totally the length of the telescope increases by 4f. So, that is about telescope. Generally, for astronomical telescope, even the image is inverted, there is no problem, nothing is wrong. you can easily observe the heavenly objects. But to see the objects on the earth, that is in terrestrial telescope, such erecting lenses or erecting prisms in case of binoculars are used. Now, due to refraction through several lenses, the image intensity decreases actually, and of course the space it occupies is also very large, and to see the field of vision or the field of view of the stars is very large, the aperture of the object lens should be more. So we use large aperture lenses in order to have large field of view, and also the brightness of the image or the quality of the image depends upon the light gathering power of the lenses. Therefore, if you have a lens of large aperture, it can gather more light from faint objects such as stars. That's why a large aperture lens is being used. But it is difficult to prepare such heavy lenses because of their weight. It is difficult to even provide them a frame to support such heavy lenses. So that's why, in order to avoid these problems, that is to avoid these optical effects like chromatic aberrations, spherical aberrations, and the problem with supporting such huge lenses and making of such lenses is also difficult. So reflecting type of telescopes are developed by Newton and others. So in the place of objective, a mirror, concave mirror of large focal length is used, and instead of spherical, a parabolic mirror is used, so that what happens, spherical aberration can be avoided. Since we are using mirror, chromatic aberrations also can be eliminated. And the reflecting type of telescopes consists of such a concave shaped mirror as objective. The rays coming from a distant object, they get reflected towards an observer sitting at the focus, where he is sitting in a cage. Through an eyepiece, he will be observing the fine image. But to overcome this problem also, A.P.Second developed a method such that the rays after reflection from the parabolic mirror is made to fall on a secondary convex mirror. That's a convex mirror, and these rays are reflected back again towards the center of the parabolic mirror, where there is a opening, a hole is there. So a hole is there through which the rays passes towards an eyepiece. Here is an eyepiece. So through this eyepiece, the image of the distant object is observed. So the image formed by reflection at the parabolic mirror and at the convex mirror is observed with help of an eyepiece. So this is known as A.P.Second type of telescope, and this type of reflecting telescopes are now in use in India also. So using such telescopes, you can observe heavenly objects in a small space itself. So if you use a refracting type of telescopes, they occupy large space, and constructing such telescopes is also very difficult. So with this, the concept of optical instruments is over. So I completed all the topics in this chapter, and you can go through the notes I am sending to you. Okay, bye.